This is Bobo, my pet dog. He loves taking walks in the park and performing tricks, especially when there's a reward involved. These are skills that he has honed over time with a lot of patience and practice. But can these skills that come so naturally for our pets be applied to the next generation of robotics? Some researchers in Los Angeles think so.
The question of how evolution has led to animals that can do fantastic behavior is a fascinating one. You walk around in nature and you see, oh, cats, they can do a lot of stuff. Oh, that's normal, right? But what I enjoy doing is asking the question of how did over millions of years such solutions evolve and come to happen? So as an engineer, if biology has these tried and true solutions that have worked over millions of years, shouldn't we be learning from them?
For Francisco Valero-Cuevas, inspiration can come from anywhere, even his own living room.
Kleo is our cat at home. Kleo can just do everything so gracefully. And so we were thinking, wouldn't it be interesting to learn how to build quadrupeds that can teach themselves to walk?
That idea, teaching robots how to learn to walk, is as difficult as it sounds. But in his lab at the University of Southern California, Valero-Cuevas and his team of students and PhDs are making progress. The professor and students work together closely, monitoring each development of the robot's learning process.
We're using a combination of multiple sensors on either side.
Instead of simply programming a certain set of actions, the team has given Kleo simulated neurons that mimic the way information is sent to the spinal cord of a living being.
It's an all-in-one system complete with a battery, so it can move on its own.
A motor, which acts as a kind of artificial spinal cord, learns which neural connections can trigger a desired outcome, in this case, walking. It's an innovative process known as reinforcement learning and can work even when not all of the robot's parts function correctly.
Here are robots that we did not teach how to do anything. We only enabled them to learn quickly.
Okay, want to go? Let's go.
Just a few meters away, outside in the courtyard, another USC professor, Quan Nguyen, is taking his four-legged robots for a walk. Professor Nguyen and his team do similar work, but their primary focus is making robots that can overcome the obstacles found just about everywhere in nature.
In order to bring the robot to some real-world application, we really need to prepare for the robot so that it can be able to adapt to, unseen environments and unseen terrain.
Nguyen's team has developed a new control algorithm that, unlike previous robots, allows them to react to things like carrying heavy weight or walking uphill. Still, they admit there is a long way to go before the robots are able to function entirely on their own.
If you think about animals, right, they have a vision, they have hearings. So similar to the robotics, we need to apply different sensors onto the robotics to be able to collect data from the environment.
Whether at Oxford, Stanford, or USC, one thing each of these scientists seem to share is an abiding appreciation for the wonders of the natural world.
People are looking in nature to see whether we can get inspirations that are much, much smarter than the engineering systems.
I'm very preoccupied of how we can use technology to improve people's lives when you have a disability. There are opportunities for robots to help you.
We are going to utilize the best of the technologies and create a new sustainable world.
That makes me feel really hopeful for the future. If we can find bio-inspired ways of building materials, doing engineered processes that are less damaging to the environment, then that has to be tech for good.
While it's still unknown just where this next generation of bio-inspired intelligence may lead us, one thing is certain: a future in which robots play a part in everyday life is already nipping at our heels.